Okay, we are live. Welcome everybody to the node.js security meeting, last one of September. Um, Before I start, does anybody have an announcement? I don't think so. Okay. As usual, we go to our agenda. So I will gently ask to you folks include your name to the minutes. I'm going to send in the chat. Oh, I copied the wrong message. Right, it's in the chat. Um, okay. Vulnerability review. Let me double check that. Nothing has changed since last meeting, apparently. Yeah.
Sorry, the only one I'm aware of is asking about the OpenSSL update, but otherwise
Yeah,
nothing
but
else new.
mhm. Uh, OpenSSF monitor review, and apparently not has changed as well. Okay, I'm going to merge that. And we have the the pull request number 54364, add WDAC integration from Windows to Node.js. I would like to
Yeah.
elaborate.
Nice.
Yeah, go ahead, Robert.
Yeah. Okay. So hi. Um. So I'll just give a brief status update on the current progress of that, and then I invited Mikhail to this meeting because he is stewarding kind of the code integrity work on the Linux end of things. Feedback from last meeting was to add more documentation and then slightly more test coverage and emit a warning when launching in code integrity enforcement mode. I've done most of those things, and I'm sitting on the changes locally. As for documentation, I'm working with some of our internal documentation teams because there seem to be a little gaps in documentation on the official Microsoft side. So I'm working with them to kind of close those gaps before I push out the changes on my end. And I think after maybe a brief discussion with Mikhail about the implementation on Linux, I anticipate there might be a couple changes with some minor changes with the implementation on the Windows side. Uh, it should all be coarsely the same, but it sounds like there are two toggleable settings by administrators for the Linux side that will likely want to mirror for the Windows side. Um, so yeah, that's what I have in updates. Michael, would you like to start give a brief explanation of kind of how we expect this to work on the Linux side and maybe some timelines or anticipated timelines on when this stuff will go live?
Yeah, hey everyone. Um, so yeah, I've been working on this script execution control for Linux for some time now. But I guess we finally found a good enough design for that. So yeah, we got a lot of feedbacks from the last patch release I sent this summer, and I plan to send a new patch release really soon. Maybe next week or yeah, um, very soon. Um, so yeah, the approach is a bit different than the Windows approach. So let's say the approach is kind of minimal. The idea is to be able to leverage existing Linux access control systems. Um, and yeah, in a nutshell, the interface is split in two. There's one, an extension of the execv at syscall to check if a file, if a regular file, will be, well, is deemed executable by the kernel. And yeah, that takes into account file permissions, endpoint options, and LSM security policy. And the other main change is,
Question,
yes,
like
yeah,
there's already the X setting, like when you chmod a file, it says it's executable or not. What's the difference in, like, it's obviously different, but what, just quick overview, the difference would help me.
yeah. So yeah, this the access and if access ads is called, and this is called may check the file permissions. They can also check if a file is on an executable mount point. But that's it. It doesn't, I mean, it doesn't take into account any other restriction that could occur. For instance, that could be enforced by SC Linux, landlock, or whatever other accessible system. So it's yeah, it's not designed for security check. And the second thing is, and I would guess the most important one is that it is not used right now by script interpreters. So we
right.
need to have a good compatibility, backward compatibility story, to be able to configure somehow to give the system administrator or the Linux distro mainers the ability to incrementally enable this feature for a set of enlightened script interpreters. And that is the purpose of the second main change, which is to extend, well, to add two new secure bits. So these secure bits are mostly used nowadays to restrict furthermore the root accesses. But the idea is to extend these bits to add two new ones. One to, well, that would be only information from user space, well, for user space. If, well, the coding process should restrict or not script execution according to the exhibit at syscall return value. Which, by the way, doesn't execute anything, just check stuff. So there's a new flag, which is check, which is passed to syscall. And the second secure bits is for the script interpreter to check if it should deny any interactive execution. So for instance, to pass, well, in a nutshell, to execute or interpret whatever might not be checked by the kernel. So that might be user input, that might be comments passed as arguments, or this kind of stuff. So that's in a nutshell the idea. So yeah, it is kind of a simple interface, and the idea is really to close the gap for any Linux access control systems to be able to really check execution permissions thanks to the enlightened script interpreters. So yeah.
And is this enabled by the process, or we will need to check on every script execution call?
So so the idea is to enlighten most script interpreters. So there's ongoing work for the Python side. There are also folks interested to work on Bash or Dash, I'm not sure. And we also need to patch libc to have a constant, security model. And the enforcement is, the enforcement is only done by user space, so only done by script interpreters, but they kind of read the policy from the kernel. So the idea is to have a constant security policy across the whole system. And this secure bits, these flags, connection flags, are set per process and inherited by all the children, future children processes. So let's say, for instance, you want to enforce script execution control on a container, only on a container. Then you can launch this container with this bit set. And of course, if this container contains enlightened script interpreters, they will check if they should restrict or not executions, and then enforce this restriction. So yeah, that's a way you can, for instance, have some system services or some containers being restricted, but not, for instance, sysadmin shells or some user sessions. Yeah.
Okay.
In our
Okay.
case, Raphael, though, like in addition to like, obviously the main node script that's loaded would probably have to do the check, but I think that like almost any require, we would need to say, like, if you're requiring this, we would have to do the check. And that could lead to some interesting things. And like, we can require just to get like the contents of the file for data. But I suspect that would still need the, like, I don't know that we'd be able to tell the difference between those two.
So yeah, maybe I didn't understand well the question, but this is, I would say, only a building block to close a limiting gap, and we need to have a, well, for this to make sense on the system, I mean on full system, we need to have a constant security policy. Yeah.
Right. No, I was just like in Node, as I understand it, we would have to make this check when we read in, anytime we read a file that we were going to pull in code that we might execute, we would need to do the check. And there's just like, there's a common case where you do a require, you basically say like, I'm requiring another module that's going to load some code, which we're going to potentially execute. The interesting wrinkle is you can also use that just to read in like a JSON file, which isn't executable. And like, can we actually tell the difference? Maybe we can based on the like the ending or something. But
yeah. So at the end, the duty of defining what should be called or not, of course, is a role of the script interpreter.
Yeah.
So.
And I guess, are you going to go on to, like, I understand this part is it lets us, like, somebody can set, yeah, this should be considered code or not code. The other Microsoft proposal then has like some integrity checking as well that factors into that. So I'm assuming you're going to move on to that.
So obviously, if you want to have a secure system, and if you want to control every kind of execution, you need to have some kind of integrity story, of course. So there are several features in Linux that can provide that. So for instance, FS Verity, Gem Verity, or even IMA. So you can kind of use these building blocks again. So you need to build a system with that in mind. And we also upstream last week, 2 weeks ago. Well, it will be for in Linux 6.12, a new LSM, which is called IPE. And the goal of this LSM is to use, let's say, to add another layer on top on the GemVT device to enforce a security policy and to, authenticate this source of data. And of course, one of the goal of that is to control the execution of everything. But of course, we need some kind of way to nicely and cleanly check scripts. So that's one use case. But there are other use cases. And so, for instance, Chrome OS is is restricting the use of scripts in some way. They are, but because it is a custom tailored distro, and they can enforce, well, they can make sure that everything works as expected, and they don't have the, well, let's say they have the luxury of not having to deal with dynamic configurations, because they can vote that for the whole interpreter, whatever, whoever is calling this interpreter. And yeah, they're basically doing that with fxs at checks, and I guess also an fstat at check too. But yeah, it's a bit hacky, but it works for the use case. But they would like also to have a more generic integration upstream, and to, of course, not deal with downstream changes to script interpreters.
So if I understand correctly, like would the script interpreters have to do like an additional check for the integrity part? Like this new bit you were mentioning, you can say, is this actually allowed to execute or not? Like something that should be executed or not, and that could say yes. And then
Yeah.
it would be like a separate check to say, okay, and now check the integrity of that.
No, the script interpreter only asks the kernel if it should interpret this file, and
Right.
that's it. And after
Okay.
that, the integrity and whatever the security check you want to enforce, well, the system interpreter wants to enforce, these are enforced through LSMs or other SNX security policy, landlock, or whatever, or mount point options, so yeah, the idea to make it really simple for script interpreters to only request if it should execute some file. And yeah, all the commission, all this stuff should be delegated to something else.
Okay, when you say LSM, what does that stand for?
It is not LSM. It is what do you mean?
Well, you're saying it's like, I don't know, there's just a few acronyms, like I thought you said LSM,
Oh yeah,
which
sorry.
like
Yeah, so LSM stands for Linux Security Module. So
okay.
they are kind of extended security mechanism for Linux. So some of them are enabled by default, some are not, some are only enabled for some distros. So the main ones, well, the main known ones are, for instance, AppArmor, SNLinux, Landlock. I'm also the maintainer of Landlock, Yama, and IP, the new one, IMA for integrity checks, and this kind of stuff.
Okay, so from our perspective, all we'll have to do is make this call that says yes or no, and like the no might be because it was never set to be something that should be code, or it could be yeah, it was set, but the integrity check failed, and some plugin modules determined that. And okay, no, that sounds good. Thanks.
So
okay.
you have one check to do per file,
Right.
and one check to do at startup to know your configuration, if you should enforce or not,
Right.
Stuff.
Yeah. Okay.
I've been wondering, I believe that the Microsoft approach will basically need to pass a flag like policy integrity or something like that, and it will enable the check based on their map access, as far as I understand from last meeting. And from the Linux side, we will need to we can use the same flag, but the difference is that the byte to check for every file or every execution script is in a different location. And I also imagine that it won't be accessible for all Linux distribution, at least on old kernel versions, of course. So from a Node.js perspective, I was wondering if we need to create our ARM configuration map, and once they use that policy, we apply the policy map or for instance, the Node.js configuration policy. It's a JSON file that if someone uses the policy integrity on a Windows, will read that file and apply to the Windows map. And if it happens on Linux, we will apply that on the Linux system. But I also feel that it will be very hard to maintain.
Yeah, so I don't really know about this JSON file, but
No,
yeah, one thing to keep in mind is, of course, well, Node.js or any script interpreters, well, the idea is for them to be kind of usable by restricted users. By users, I mean processes, so services or whatever. And these processes control the context, the agent context. So they control the environment variables, for instance. So that's why we need to patch libc to for instance, to handle LD preload or LD library path, these kind of sensitive variables, and to also check if every shared object should be used or not. And so, yeah, we should need to keep in mind that every configuration files read by script interpreters, well, must be trusted. So if, for instance, the script interpreters looks at a path in an environment level, and from this path open a configuration file which is used to do security checks, then it will be easy for anyone to bypass any security checks.
Yeah, I think like that question does make me wonder, like it almost sounds like when my understanding of the Microsoft one is like in the registry, there would be a setting that says like, are integrity checks turned on or off? And if they're turned on, then there's a check every time you read any file that would say, has the integrity been tampered or not, right? It doesn't matter whether the code's executable or not. It's just like all the code. And I'm trying to then, so it sounds like on the Linux side, this is more about, or at least it's described as like a code that's running. So like I assume there's still like, there's a system call, which is kind of like looking up in the registry, is this on or off? And I guess like, would it makes, would even if the script interpreter is, and I'm just thinking this through, like in theory, like, configuration files, any file which we would want to trust, it's almost like, shouldn't it be for any file that you want to,
Yeah.
yeah.
Yeah, for the Linux world, we cannot trust any file. I mean, for this use case, you cannot trust any file before, well, I mean, that's one of the reasons why we need to, well, to get the configuration from the kernel directly without passing through any file.
Yeah.
That's one reason.
But I'm more like wondering how the Linux side will cover it's not an executable file. Like it's not a file we're going to actually execute, but it's a file, it's some other file, like almost any file you could imagine wanting to make sure that you have the integrity checks in place.
Okay, yeah, that would be a next step.
Okay.
Yeah, so you're asking how to check if a file should be trusted or not, a configuration file. Right. So that is
Any
definitely
file, right? Like I think the Microsoft proposal that we've understand so far it wasn't just for code. It was for like any file you're going to read, there would be a check that says, yeah, that wasn't tampered with, so go for it, right? Versus some being trusted, some not being trusted in it. So it's just a little different.
So the current approach for Linux is only focusing on code integrity, executable code integrity. So the initial assumption is every code running on system, every script interpreter's binary code is trusted. And we want to be able to extend this trust to scripts which are not interpreted by the kernel. And yeah, then, well, every code, every trusted code, like anything, including script interpreters and also scripts, will need to be carefully developed to to take it into account this potential threat. So if they open any file, let's say a script open a random file and kind of read this file and then call eval on it, well, that could be used by an attacker, but in this case, that's the responsibility of the script writer, the script developer. So yeah, that's why there are some assumptions. If you want to control everything and to have something consistent, well, we need to have a integrity check, authenticity check, and to make sure that the executable code doesn't do harmful things and potentially stuff that could be used by attackers. So yeah, that's not a simple problem, but yeah, we need to.
I guess I'm still like, I kind of understand. I understand the like, hey, code is most important, but like, I'm wondering if like just a more generalized, like, I guess you don't want to do this check on every file because it costs you more, right? Or something like that.
Yeah, and so if you take a look at the slides I talked about last week when I gave
I'm
a
looking
talk
to it now.
about.
I'm sending the chat.
Yeah, you'll see. So I did propose several approaches, and one of them actually was to create a new trusted for syscall. And the idea was to be able to check code, but also, for instance, configuration files. And that was rejected. And the main reason for that is we need to have a really clear semantic. And well, we already have that for executable code, but it will be something new for configuration files or this kind of stuff. So the approach right now is to kind of minimal changes and to be able to extend what the kernels know. So only should we execute this file or not. But yeah, after that, if we want to have other kind of integrity checks, we could either implement that in kernel or fully in user space. But for sure, what we need right now is, for other access control systems, for instance, SE Linux, there is no, be able to interpret a configuration file is not an access right. So that's really kind of the frontier between access control and semantic checks. So, yeah.
So I'm just trying to understand, because it almost sounds to me like, say, the implementation in Node for the Microsoft integrity checks and for the Linux code execution checks might actually have to be a completely different set of checks, right? Like in one case, I think it might be integrated into the read file. Like I'm reading a file, do the integrity, check, is the integrity good or not? In the other case, though, it'll be like, oh, I'm reading code which is gonna be executed, do a check. And like those are two different places where we would need to, because like in one case we just do it for every file. In the other case, you need to know, oh, this is code this is a read that we're going to use as code, right?
Yeah. So yeah, also, right now there's nothing like WDAC in Linux, so Windows is much more advanced on this step. So yeah, we'd like to kind of close the gap a bit, at least for execution code for Linux. But yeah, we need to Well, that is the first required step, and then from that we could build other kind of checks, But yeah, Windows is much more advanced on this part.
Okay, so it'll be interesting to see like how integrating. I guess maybe I think up front it was mentioned that Linux one was going to introduce maybe two things. So maybe we'll see how the people who thought more about it have figured out how to integrate them into the one set of changes.
All right.
So yeah, maybe last word. Yeah, I plan to send new batteries soon, very soon. So would you like to be CC'd to receive the batteries too?
Yeah, that's great.
So yeah, please maybe you can pass in chat the email address I will use.
For the LSMs that exist, like I'm wondering in some senses, like, does if there's an integrity check system, does whatever run that's running actually need to know? Because like could those LSM just say, oh, I've detected that a file's tampered. You go to read it, it says no, you can't read that. Right? Like, does it even need integration with the actual script interpreter in that particular case? Yeah.
So what do you mean for the
Well, I'm just
question?
like, I think like my understanding, and I may be forgetting a little bit, was like the original Microsoft integrity check idea is like they want to say, well, like, hey, your files haven't been tampered with, right? And
Yeah.
so when you're interacting with the files, you do a check, it says, yeah, it wasn't tampered, or yes, it was, and it was. I'm 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 now wondering, well, like, why does the actual program need to worry about that versus the operating system saying, well, I'm not going to let you open. Like, you go to open a file, if it's been tampered with, it just says, well, I'm not letting you open it, right? Like, and that wouldn't
Yeah, I
require
guess.
any integration. And I'm wondering, you probably already build that with some of the Linux APIs.
Yeah, maybe Robert, you want to?
Yeah.
Sorry, could you just say that one more time?
I'm wondering like so like I think, and correct me where I'm forgetting, like, but the original intent and discussion was around like, hey, we want to make sure that files haven't been tampered with, right? So when you open a file, we're going to check and say, has it been tampered with or not? But
Yeah.
I'm now just thinking out loud as to why doesn't the operating system just tell us, no, you can't open that file because, and like, we don't know why. It
Mhm.
just, the error code could say tampered, and that's
Yeah.
the end of it, right? And like, that wouldn't require any integration at all. But there's got to be something I'm forgetting on that.
Yeah, this is kind of for flexibility on systems where you would kind of want to read in a file that could potentially like there's a set of files that are okay to change during the runtime, and there's a set of which could be like various data files. Just pulling something out of it, like maybe like an image or like a JSON file that you're using to store data, like that are totally intended and okay for the application to change during the runtime. But for things like code, we want to make sure that the code that the application's actually executing is never changed while the application is running. So we want to make a distinction between reading a file that is just data and we can expect it to change versus reading a file for execution and we don't want that to change.
Okay, so even and again, that's partly the part that I may be forgetting is like on the stuff that you've been working on, it is really just going to apply to code or executables versus just any read.
Yes, that's correct. We're
Okay.
trying to
Okay.
plug in where we're reading code off disk and then
Okay.
intercept. Yeah.
Okay. So then it's much more consistent. For some reason I was thinking it was like every file, and then you could basically set it file by file, but makes sense. Okay, got it.
Mhm.
One last question, Michael. Sorry if I'm not pronouncing your name correctly. Mikhail. Is there a presentation video? Because I only can see is the slides.
Yeah, it was recorded. Well, it was streamed for sure, so I'm pretty sure it is recorded. We should be able to find this maybe by replaying the live stream. I'm looking right now.
How long ago was it?
Yeah.
I found one a year ago.
My name is Ikesa.
It was a week ago, I guess.
Okay, so it's
Oh,
not
yeah.
that.
Yeah, okay, if you go... Okay, I'm looking at the room number. There's a way to find it.
And while
So
we're
it was...
pulling up the video, if I might interject with what I'm anticipating is just a minor change with the implementation. So on Windows, we were talking about hiding or gating this code integrity and script interpretation or interactive mode check behind one large flag, which is uh, like it's not the registry, but you can sort of think of it as the registry, but
Okay,
basically a
whatever.
CI policy. But yeah, behind one flag, which would be a discrepancy from the Linux implementation. We were talking about hiding it behind just enable code integrity. And if this flag is on, we're going to do the checks when we require files. And then we're also going to disable interactive mode all under the same flag. With the way it's being done on Linux, there are two separate flags, one for enforce code integrity and one for innate or I don't know if it's a enable or disable interactive mode. I think it would be a secure flag to disable or to enable interactive mode, but there are two flags on Linux. If you like, I can just mirror that implementation on Windows. So we have a separate flag for um, allowing interactive mode and a separate flag for just doing integrity checks on requires.
Yeah, I think two flags are great. Because we might find something very a nasty edge case on a specific behavior on running it without um I mean, if we only check for integrity, that can be more useful for users than running it on every require, for instance. And it also way easier to make it possible or land it on Node.js since we are doing small chunks of code instead of a big feature, if
Okay.
I'm understanding it correctly, yeah.
Okay. Yeah. Okay. Cool. So I will do that, and then oh, sorry. One final thing. So in order to add settings to policy to a code integrity policy. So the code integrity policy setting section is kind of arbitrarily configurable for these various flags, and we need the runtimes or basically any application who's anticipating using this secure settings store to publish a manifest of the settings that their application is going to query for. So it just basically defines for someone who's writing the policy what configuration options are available for them. So
Mm-hmm.
Node would have to host an XML file somewhere that contains these policy setting definitions. I can work. I just That was not part of my first pull request, but I'm gonna add that in as part of the documentation, and just want to make sure that there is a place that this can be distributed via.
Um, my suggestion is to not have it in the first iteration, and let users that want to use that feature to create that configuration file manually, and then we go to a second one that automates or at least hosts that file in the documentation. Currently, it can be any arbitrary XML file, right? It doesn't need uh, to be part of this feature right now, or does it?
Uh, yeah, so it's a subtle difference. It would, um, in order for the application or the application to query the settings store, um, well, you don't need to define a manifest, but in order for policy writers, so the system administrator, when they're authoring their policy of like, hey, enable Node.js code integrity, they need to know what policy settings are actually available for them to configure for each application. And these settings have to be
Ah, okay.
declared somewhere. And so Node.js would declare the set of settings that they query for. Python declares the set of settings they're querying for. Like Windows PowerShell could declare kind of its set of settings that it queries for. So it
Mm-hmm.
just needs a more structured.
Ah,
We just need
okay.
a
It's more
structured
for the
definition.
documentation itself than
Yeah,
anything. Okay. Yeah, I
So
think it can be a part.
it's not anything that needs to be shipped, right?
No, just documentation. Like, this is our
yeah,
set of rules.
Okay, because
yeah.
that's okay, but otherwise, like we don't ship anything except for the node binary in the
Yep.
upstream.
Yeah,
So it's
that's yeah, no, that's acceptable. As
but
long as
like
there's kind of a well-known place that when an author like in the
right.
node document, just hey, go to this website. This is the XML file that declares kind of the settings we query for, or something.
Yeah,
Eventually,
like
we can have a flag that will create that for users. For instance, dash dash create policy integrity, and it will create, but it needs to be dynamic. We don't ship it.
the equivalent is with OpenSSL, there is a configuration file. So we look in a well-defined place and in a well-defined section within that file. Like so we don't ship any OpenSSL configuration files, but if there's one on the system, we look for one in a particular place with this particular section, and that's documented. So I think it sounds similar in this case. It's like not anything else. If there's nothing, like we don't ship anything, so if you just install Node and don't have one of those, we'll read and say, oh, there isn't one. But if there is one, we read it and can respect what's there.
Um, it it's similar in that you don't need to ship it, but it's a slightly different. The purpose of the file is slightly different, but I think in spirit it's very similar. I think if I just put the file, if I just add it to my pull request in the documentation, it might make a bit more
Yeah,
sense on its
sure.
intended use case. But yeah.
Yeah. I'm just saying, like, if it's in a similar model where a file can be there, and if it's there, we'll use it. That's okay. Although even in that case, I know we've had like security reports and
Mhm.
related, because then you have another file that needs to have is potentially trusted to affect them.
Mhm.
But yeah, I
Okay.
think your documentation is the right place to
Okay. Cool.
share
Sounds
how that
good.
would work.
Okay. Um, Anything else? Like, do you need any other help for the pull request itself? Like something is failing, Cody, or something?
Uh, no, I think I'm on set up pretty good to be self-sufficient for at least the near future. I think I might have more questions for whoever would be appropriate on kind of designing tests around this because I have some unit tests,
Yeah.
but again, like I'm not intimately familiar with kind of all Node.js's internals and kind of the places that it can load files from, the different ways that it will read files off disk for execution. I'm under the impression that everything in the CJS and ESM loaders are basically the main entry point for any code that's trying to be executed. But if there are other places lingering, I'm not in. So one, I'm not entirely sure how to put these under load and test them, other than just requiring random stuff in my tests. So any insight into that would be great. We don't have to discuss it now. I can re-ask this question and the pull request so it's closer to the actual code that I'm intending to review. But
Okay.
that's just the immediate thoughts on my head.
I
Uh,
assume you mean like require or import, right?
Correct. Yeah. So
Okay. The other one that comes to mind is loaders. So
okay.
there is some functionality that basically I think gives you a shot at the code before it runs.
Okay.
So I don't know if that would matter, but like that's one that I would think would be worth checking out.
Okay, sounds good. Yeah, because at the moment I just looked at Raphael's pull request where he removed the policy related code integrity
Yeah,
checks and basically re-added the Windows code integrity checks where it made sense. So if it's outside of kind of what the policy was doing, then I don't really know if then it's not going to be covered, I guess.
yeah. I mean, loaders may have started after that initial poly, like that other stuff was
Okay.
there. I'm
Cool.
just thinking like it's another way where you can affect the code that ends up running because it's meant to be like, hey, yeah, you've loaded this code, but you know, we want to do some transformations or I, they're basically files that could run.
Okay.
And anyway, worth just looking at the loading loaders feature and see if you think it matters or not in terms of what you're trying
Okay,
to do.
will do. Yeah, appreciate that. I'll make sure to do that. Thank you. So that's all that I had to talk about today. Thank you for your time. Uh,
See, Michael has his hand up.
Yes. Just well, be sure I understand clearly. So, about the JSON files we were talking about, is it so? First, is it currently used in Linux?
no, this was just one idea to have
Okay.
a global configuration for Node.js that works cross-platform. But thinking more about that will be just a
Yeah.
lot
Okay.
of maintenance burden for us.
Yeah. Good. Yeah. And yeah, that will also be well more difficult for system administrator, to configure security policy. If they need to go through a lot of different configuration files, well,
Mm-hmm.
that will make the story more difficult. Okay, good. And yeah, and last question. So, the current proposal for the next kernel is ongoing. It's not met yet. I hope soon this year, in the next month, maybe. But yeah, it looks like it's well, we found a good design, but I was wondering what do you think about the current approach?
Sorry, I think I don't get a question.
So yeah, what do you think about the two kind of checks for the Linux system? The execv at check with big flag to check if a file is executable or not, and the configuration flags.
Okay. I think that makes sense. Uh, I would need to look to the implementation on Node.js to see how it's going to be better for users, but I suspect that should work. You mean one is execv at, and the other one is the config flags, right?
Yeah, yeah,
I think I don't know. To be honest, I would need to take a look with more
yeah, sure.
home to
So
the code.
Yeah, sure. Yeah, I've been working with a Python developer, and so in the slide you'll see at the end a few links, and one is pointing to a proof of concept with so that will not be the final version, but that might give you an idea how to implement stuff. And in the next batch series, I will also include a really simple toy interpreter, a script interpreter, and to kind of
Okay.
show with an example how we should use these changes.
Okay. Okay. Sounds good.
Okay,
Sounds good.
thanks.
And you mentioned sharing some things. I think the best way would be to, like, if you could open an issue in the repo and post the links in there, because that would give us like a persist versus email, right? That would give us a persistent place where we've got links, and anybody who comes
Yeah.
along here, we don't have to forward things along. And
Yeah, so
Here's the best.
links about what? Which part?
like you were saying, like, hey, do
To
you
the
want me
patch.
to share the patches and stuff like that?
Oh, yeah, okay. Yeah, just
It-
okay.
I
A
think
place
that's
If you
to
just
good.
open an
explore.
issue in the security working group that's like,
Okay.
advance info on integrity, what or whatever, code execution stuff in Linux, and then paste all the stuff in there. That would
Yeah,
make it
sure. Makes
more
sense.
easy to share across collaborators versus just individuals who get emails and stuff.
Yeah, sure. I'll do that.
Sounds good. It sounds like Raphael got cut off on Zoom, but I think we're still okay.
Okay, I'm back.
Oh, you're back. Okay. Yeah, I was going to say, I was just typing in the chat, but we've been okay the whole time. So,
Okay, so the live is still working. That's good.
yep.
All right. So, is there an ongoing question or something? No? Okay, then. So, thank you, Robert and Michael, for joining us. That has been amazing. I'm looking forward to the implementation, how we can apply that to Node.js and see our users using that. Um, we'll have another meeting in 2 weeks in case you want to join to ask questions or give some feedback if you want. Other than that, thank you for joining. Thank you, Michael.